Hello everyone, it's Miss Thomas, and today we are going to look at standard form of a line. So our objective is to write and graph an equation of a line in standard form. So standard form is just a different way of writing a linear equation. You always know you're dealing with linear equations because you'll have your x and your y, your variables won't have any powers to them. So standard form is ax plus by equals c, where a, b, and c are all integers, and z is just our little set notation for integer. And a is always going to be positive. So just to be clear, because they are integers, that means that there's no fractions, no decimals. Or square roots or anything like that. So sometimes we need to clear the fractions to get things in, to get those variables or coefficients in integer form. So you can always do this, and it actually makes solving some equations easier to clear fractions. So all you need to do is make sure you multiply both sides of the equation by the lowest common denominator to clear the fractions and to create an equivalent equation. So if we wanted to write this equation in standard form, my x and my y are on the same side of the equation, which is great, but I've got these fractions. So when I think about these denominators of 5 and 2, 10 is the lowest common multiple of 5 and 2. So I'm going to multiply this entire equation by 10. So the same as multiplying by 10 over 1. So that means I need to multiply every single thing by that 10. So 10 times my 3/5 x plus 10 times my 1/2 y equals 10 times my -2. So everything in black is from the original equation, and then the red is distributing that 10 in. So what happens, because our 10 is over 1, the 5 and the 10 will cancel. So we'll get 2 times 3, which is 6, over 1 times 1, which is 1. So we'll end up with a 6x here. And then the 2 and the 10 will cancel, so that we're left with 5 in the numerator and just 1's in the denominator. So 5 times 1 is going to give me a 5y. And then 10 times -2 is just going to give me a -20. So this is an equivalent equation of what we started with, but all of our numbers now are integers, so we're ready to go. So this is standard form. So sometimes we need to clear decimals, and with that we multiply by a power of 10 to get rid of decimals. So 10, 100, 1,000. Write this in standard form. This time, because I have something in the tens place for both of these, I'll just multiply by a 10. So when I distribute that in, 10 times 0.2 is going to give me 2x. 10 times 3.4 is going to give me a 34. And 10 times the 1 is going to be a 10. So I am now in standard form. When my leading term, my x, is a negative, I again cannot have that. My leading term needs to be a positive. So you multiply the entire equation by a -1, and all that's going to do is change the signs. So you can always employ these strategies when you're solving or graphing. You just have to make sure you do it to every single term. So writing in standard form, you're going to use addition and subtraction to move the x and y terms to one side of the equation and the constant to the other. And then we want to use multiplication to eliminate any fractions, decimals, or negative leading coefficients. So if we have y equals 1/2 x minus 3, we're currently in slope-intercept form. We want to get into standard form. So what we're going to do is try to get our x over with our y. So as I said, I'm going to kind of keep writing this line to keep my equation lined up. So trying to get my x term over, I need to move the entire x term. So I want to subtract the negative 1/2 x from both sides. Now x and y are obviously not like terms, so we're going to just write them negative 1/2 x. Because the y is positive, it's going to be a plus y, equals, this canceled, so it equals a negative 3. So we're almost there. The catch is we have this negative 1/2 x. So to get rid of the negative 1/2, I'm going to take care of the negative and the half at the same time. I'm going to multiply by a 2 to get rid of the denominator of 2, and I'm going to make it a negative so that when I distribute in, I end up with a positive 1x. And then negative 2 times the y is going to give me a negative 2y. And then negative 2 times the negative 3 is going to give me a positive 6. So we want to graph the standard form as well. And always using slope-intercept form will work, but the likelihood of making a mistake is pretty high when you're always trying to get y by itself. So being able to graph from standard form is going to save you a lot of time and potentially a lot of errors. So we want to graph from the x and y intercept. Each intercept occurs where the other variable equals 0. So the x-intercept happens at the coordinate a, 0, where a is just some value. And the y-intercept happens at the coordinate 0b, where b is again some value when x equals 0. So if we have 3x plus 2y equals 12, we don't have the y by itself. We want to just go ahead and graph from the intercept. So if I want the x-intercept, then I know because it's the x-intercept, the other variable will be 0. So I just do 3x plus 2. I put a 0 in for my y, and I solve. So I get 3x, 2 times 0 is a 0. So that's really just 3x equals 12. Divide both sides by 3 to get the x by itself. And x is going to equal 4. Now you need to be careful. That's not just x equals 4. It's x equals 4 when my y equals 0, because we plugged that 0 in at the beginning. So you want to make sure that you write the coordinate 4, 0. And that is going to be one of the points on your line. Then we want to go back and we want to find the y-intercept. And we find the y-intercept by plugging in a 0 for the x. So whatever intercept I'm looking for, I'm going to plug in a 0 for the other variable. So I am going to go 3 times 0 plus 2y equals 12. So 3 times 0 is a 0 plus 2y. So 2y is equal to 12. So dividing both sides by that 2 to get the y by itself. Y equals 6. So that is actually coordinate 0, 6, because my y value has a value when my x is 0. So I'm going to plot that on my y-axis, and then I just connect the points, and that is my line. So your you need to write this equation in standard form, and you need to graph using these intercepts.